Good afternoon, class. We are looking at section 3.4, the product and quotient rules. We looked at derivatives and rates of change, the derivative as a function, basic differentiation formulas, and now the product and quotient rules. As always, this is the basic slope, rise over run. When we take a limit and we let Q goes to P, X approaches A, or H approaches 0. These are all, by the way, difference quotients dq. That becomes the slope of a tangent line. And this is, in essence, the point slope formula. And if we generalize it at X becomes a differentiation formula in this format, dy dx is the limit of delta y over delta x as delta x approaches 0. This is the Leibniz's notation. So we have the basic differentiation formulas here. We have more here. We have the definition here. We are going to add the product and quotient rules, and I have the shorthand notation here. If anybody is familiar with the rules, I may have changed the order. And the reason I have is because if you look at the product rule, when we multiply f by g and differentiate, it's f prime g plus g prime f. And I use the same thing, change the sign to negative here for the quotient rule, which becomes f prime g minus g prime f over g squared. So that makes it a tad easier to memorize. That's the only reason. If you've learned it in a different order is fine. For example, we know that there is a commutative property for addition as well as multiplication. So you may have it in a different order, such as f g prime plus g f prime. That's fine. Whatever you've learned, it works out. And if this is the first time you're looking at it, this format will help you memorize. One thing I want to explain, by analogy with the sum and difference rules, we may be under the assumption that the derivative of a product is the product of the derivatives. And we go over the proof in regular calculus course, and I have the proof at the end. You can look at it if you like. You're not responsible for it, but let's look at it with a simple example to see that why it doesn't work. For example, if we let f of x be x and g of x be x squared, clearly their product is easily found, so their derivative. So the derivative of x is 1, x squared is 2x, their product is x cubed, and we know the derivative is obviously 3x squared, all of them by the power. However, if we were to go by f prime g prime, simply we would multiply these two, which is 1 times 2x equals 2x, and obviously we know the answer is 3x squared. So fg prime is not equal to f prime g prime as it happened for the sum and difference rule, for example. Now, here's the shorthand notation, f prime g plus g prime f. So f prime is 1 times g, which is x squared, plus g prime, which is 2x, times f, which is x. And this is x squared. This is 2x squared. They add up to 3x squared, and that does work. Again, that's not a proof, but at least it gives you an idea. I'd like you to try this at home 2 different ways. First, just distribute and use the power rule to finish the job. Second, by the method of this section, which is the product rule, you again may have seen this format or the shorthand notation that I have mentioned. Let's start with a very simple example, and we don't want to simplify. This is a warm-up example. So I'm going to call the first parenthesis F, the second parenthesis G, and I want to stick with this shorthand notation. So the first step is to find F prime, which is 4x cubed minus 6x. And I have to multiply it by G, so simply put the G next to it. Plus G prime F. So here's the G function. G prime is 6x minus 5. And then times, just put the F function next to it. And this is the only calculus step. And the only reason I have set up this in this format, and I called it a warm-up example to emphasize the calculus step may not be too many, just one, and then you take a couple of steps of algebraic steps to finish it at home. So I'm going to leave it for you to finish it at home because I wanted to emphasize the calculus step. And now we are going to look at examples with details. For example, if this function is x times e to the power of x, we want to find the first derivative as well as the second derivative. So I'm going to put a raised dot in between. And I'm going to call this F, and I'm going to call this G. So we're going to use the product rule. The derivative of F, or F, this is F prime G. Now this is 1 times e to the power of x, plus G prime, the derivative of e to the power of x is itself, times x. So I'm going to write it as follows. Here's F prime G. Here's G prime F. We factor out the e to the power of x. And now we are ready to take the derivative again. And this time, let's say this is the F function. The parenthesis is the G function. We want F prime, which is e to the power of x, times G, which is 1 plus x, plus G prime F. The derivative of the parenthesis is just 1 times e to the power of x. And I'm going to write F prime G plus G prime F. And as you can see, I can factor the e to the power of x, and I get x plus 1 or x plus 2, and that's the final answer using the product rule. In this case, y equals x squared sine x. I put a raised dot between x squared and sine x. I'm going to show this as f times g. So I need f prime, which is 2x squared times g, which is sine x, plus g prime, the derivative of sine is cosine x, times f, which is x squared. So I'm going to write at top of it. It's like f prime g plus g prime f. And all we have to do, just put the x squared in front. It's awkward to put it afterwards because one may be under the assumption this is x cubed, which is not. And we are done. So a couple of examples involving the product rule. Let's look at the quotient rule. Again, this is a warm-up example because we are concerned with the first step only. A simplification which takes a couple of steps or all algebraic, and I want you to finish it at home. We're going to call the top the f function, the bottom the g function, and we're going to stick with this formula. So the very first thing we need is f prime, and we know f prime is 4x cubed minus 6x squared. So that's f prime times g. Just next to it, write the denominator times 3x squared minus 5x minus g prime. G is 3x squared minus 5x, and g prime is 6x minus 5 times f, the top function. You just write next to it over g squared. Basically, just write the denominator in the parentheses and square it. That's all there is to it. You really don't have to do much. And as you can see, you're done with your one and only calculus step. And now you have to take several steps, algebraic steps, to finish the job. I'd like you to do that at home. We are going to move on. We want to differentiate this, and we are going to use the quotient rule. So let's call it f over g, which means x squared minus 3x is the f function, x minus 1 is the g function, and we're going to stick with this quotient rule. So I'm going to need f prime, which is 2x minus 3, times g, which is x minus 1, minus g prime. The derivative of the bottom is simply 1 times f times the numerator, which is x squared minus 3x. And then in the denominator, you just write the old denominator and square it. So I'm going to write at top of it here's f prime g minus g prime f, and here's your g squared. On a normal basis, we keep the denominator intact. We don't change anything because sometimes it gets multiplied. Now we are going to FOIL 2x times x is 2x squared minus 2x minus 3x, they add up to minus 5x plus 3 minus x squared plus 3x. As you can see, this was the only calculus step. Now we're going to go with algebra. We're going to combine 2x squared and negative x squared, and we get x squared. We're going to combine negative 5x and positive 3x into negative 2x, and we write the constant 3, and we are done. So a lot of algebraic steps, one step of calculus using the quotient rule. We're going to continue, we're going to differentiate this. So to do that, what is our first step? What do you think we should do first so we can differentiate this? Anybody? We're going to change square root of x to x to the power of 1/2. We put a raised dot in between, meaning we are going to use the product rule. So f prime, you're taking the derivative of x to the power of 1/2. That means 1/2 x to the power of negative 1/2 times g, which is e to the power of x. So this gives you 1/2 x to the power of negative 1/2 times g, which is e to the power of x, plus g prime. The derivative of e to the power of x is itself, times x to the power of 1/2. So this is f prime g plus g prime f. And again, I put asterisk next to it. The calculus step is done. We are going to take the exponent negative 1/2 down, make it positive 1/2, and x to the power of positive 1/2 is the square root of x. We make the change. Now, we're going to combine the two by taking a common denominator, simply because later on when we do applications of differentiation, we need to put it in a format so we know where the function, the differentiation function is 0, where the differentiation function does not exist. So if we take the common denominator of 2 squared of x, so this is simply e to the power of x, plus, if I write this in a different color, then in order to raise this, I need to multiply by this denominator, which becomes 2 square root of x. And as you can see, the numerator is e to the power of x plus e to the power of x times 2x, or simply 2x e to the power of x. And I can take a common factor of e to the power of x out from the numerator. And this will be my final answer, or this one. Makes no difference. Both of them mean the same thing. It's just important to see they both are equal. So differentiation using the product. Here's the next one. Y equals e to the power of x over 1 plus x. We are going to write this as f over g, emphasizing we are using the quotient rule this time. So if we call this f, we need f prime, which is itself, e to the power of x, times g times 1 plus x, minus g prime, the derivative of the bottom is simply 1, times f, which is e to the power of x. And the denominator, just write it by putting it in a parentheses and squaring it. You don't have to do much. So I'm going to put at top of it this is f prime g minus g prime f, and the denominator is g squared. We are going to distribute e to the power of x over the parentheses, it gives us e to the power of x plus e to the power of x times x. And the last piece, we just write it as negative e to the power of x. We can cancel those two. And we put the x in front of e to the power of x. And now we have the final answer. As you can see, quite a few algebraic steps with only one step of calculus, which has asterisk next to it, emphasizing the importance of prior knowledge of mathematics. Here's the next one. We want to differentiate this using the quotient rule. So I'm going to call this f over g. And we're going to use this rule. And knowing that the derivative of sine is cosine, the derivative of cosine is negative sine. So the top, I need f prime. The top gives me cosine x times the bottom. Just write it. Minus g prime, the bottom, gives me 1 plus negative sine x. 1 plus negative sine x, or simply 1 minus sine x, simply because the derivative of cosine is negative sine times f times the top, 1 plus sine. What about the denominator? Just write it in a parentheses and square it. You don't have to do much. And this is the only calculus step. Now, you have to distribute this. Get cosine x times x, which is x cosine x. You have to distribute this and you get plus cosine squared. So what I want to quickly go over, first of all, this is the only calculus step. Secondly, this part, a minus b times a plus b is a squared minus b squared, and that's why you get 1 minus sine squared x. So now we are looking at algebraic steps and also trigonometric identities. We know that sine squared plus cosine squared is 1. Therefore, 1 minus sine squared must be cosine squared. Cosine squared and minus cosine squared, they are going to cancel each other. And the numerator is left with x cosine x as the only term at top. And it's done. Again, you don't have to square that because it doesn't do anything. And if they ask you, you do that. In this example, I'm asking, do we need to use a quotient rule? It's important to understand, can I use a quotient rule? Yes. Should I use it? Not necessarily. Anytime you have a possibility of dividing, then it's easier not to use a quotient rule. It goes faster. And if you don't see the easy way out, normally the long way will not do that. So what is the process? First, change this to t to the power of 1/2 and make up two fractions. Notice this is t to the power of 1 and a to the power of m over a to the power of n is a to the power of m minus n. This is the quotient rule for exponentials. Therefore, the first one becomes t to the power of 1 minus 1/3. The second one becomes t to the power of 1/2 minus 1/3. In other words, this is 1 minus 1/3, and this is 1/2 minus 1/3, which becomes 1/6. Now, we are going to go with the power rule. So for this one, 2/3 becomes the coefficient, t to the power of 2/3 minus 1, which is negative 1/3, minus 1/6, t to the power of 1/6 minus 1. So again, this is 2/3 minus 1. This is 1/6 minus 1. And they're both negative. We take them down and we make them positive exponents. Again, a to the power of minus m is 1/a to the power of n. 1/b to the power of minus n is b to the power of n. So those are negative exponential rules that we know. I wanted to remind you again. We want to prove that the derivative of tan x is secant squared x. We want to prove this one. And for the sine and cosine, we need to use a lot of trigonometric identities, the concept of a limit and calculus. And I do have the proof for that for you. But you're not responsible for that. But the rest of them become very easy because tangent, as you know, is sine x over cosine x. Therefore, we can use the quotient rule. And that's what happens with each and every one of them. So let's call this f over g. We are going to use the quotient rule. So I need f prime g minus g prime f over g squared. So f prime, the derivative of sine is cosine times g, which is cosine, minus g prime. The derivative of cosine is negative sine times f, which is sine. And you just write the bottom and square it, which is cosine squared. So let me write right at top of this is f prime g minus g prime f. So this becomes positive. Sine squared plus cosine squared, or cosine squared plus sine squared, makes no difference, is 1. And secant x is 1 over cosine x. So 1 over cosine squared is secant squared. I highly recommend you try to do the rest of it. And you should know you can use for cotangent cosine over sine, or 1 over tan. For secant, you can use that. For cosecant, you could use 1 over sine. I highly recommend you try at least some of them with the quotient rule. It's good for practice. All right, we are interested in finding the equation of a tangent line, which means we need two things. We need a pair x comma y, we have it. We need the slope. To find it, first and foremost, we need to differentiate. So let's find y prime. If this is f, this is g, we need f prime g minus g prime f over g squared. So the derivative of the top is 1 times the bottom 2x minus 7 times g minus g prime. The derivative of the bottom is 2 times f, which is x, and just write over the bottom squared. And as you can see, this is the only calculus step. So this is f prime, this is g, this is g prime, this is f, and we can write this as 2x. We're going to distribute 2x minus 7 minus 2x. Cancel out the 2x and negative 2x. We have minus 7 over 2x minus 7 quantity squared. So we have a pair x comma y, namely 3 comma negative 3. We need to find the slope, which means m, or slope, is y prime evaluated at the x coordinate 3. So y prime of 3. If you plug in here, you get 2 times 3, 6 minus 7 is negative 1. Square it, you get positive 1, negative 7 divided by positive 1, it's negative 7. I hope everybody can see that. So a quick recap on that. And you plug in here, you get 2 times 3 minus 7, which becomes negative 1. Square it, and there you have it. Now we're going to use y minus y1 equals m times n, m times x minus x of 1. So y minus y1, that means y minus negative 3 or y plus 3 equals m, that means negative 7, times x minus x of 1, that means x minus 3. We're going to distribute minus 7x plus 21, and we subtract the 3. We get y equals minus 7x plus 18. Now, this pair works for the original function. It does work for the tangent line also because it belongs to both of them. We want to differentiate this, and on purpose, I've chosen a variable that normally we don't, to make a point here, f of m, meaning m is the independent variable, in which case the derivative of m is 1. And anything else, a constant, the derivative is 0. Even if we had other variables such as x, y, z, they would have a derivative which is 0. So only the independent variable, unless the other ones are not constant. So with that being the case, we are going to go with the quotient rule. And we're going to call this f, we're going to call this g, So f prime is 9 times g, which is 5m plus 4, minus g prime is 5 times f, which is 9m minus 7, over g squared. Just put this in a parenthesis and square that. So just to write it quickly, this is f prime g minus g prime f, and by the way, this is the only calculus step. We are going to distribute, which gives us 45n plus 36 minus 45m plus 35. So 45m, negative 45m, they cancel each other. 36 and 35, they add up to 71. We want to find the equation of a tangent line again. We need a pair x comma y. We have 0 comma 1. We also need the slope. We need to find y prime first. So I'm going to put a raised dot in between, and I'm going to use the product rule. So if we call this f, e to the power of x is f, cosine x is g. So f prime g, the derivative of e to the power of x is itself times cosine x, plus g prime f. The derivative of cosine is negative sine, so minus sine x times e to the power of x. So minus sine x times e to the power of x. So this is f prime g minus g prime f. Let's factor out e to the power of x. So we have a pair, we want the slope, and the slope is y prime evaluated at the x coordinate, y or f of x, by the way, right? So you want y of 0 or f of 0, either way. So if we plug in f prime of 0, if we plug in 0 here, we get e to the power of 0 times cosine 0 minus sine 0. Now, e to the power of 0 is 1. Let me use a different color. E to the power of 0 is 1. Cosine 0 is 1. Sine 0 is 0, and we get 1. Now, you don't have to use the point slope. Y equals mx plus b will do the job. The reason why, because b is given as 1 here. So m is 1, so 1 times x, plus b is 1 also. So the equation of a tangent line, y equals mx plus b, or y equals x plus 1. Let's look at an interesting example from trigonometry. So we want to differentiate this. Y equals 1 minus secant x over tan x. So we're going to call this f over g. So we will use the quotient rule. So we want f prime, 1 is a constant, gives you 0, minus secant x. As you know, secant x is secant x tan x. So minus secant x tan x times g, which is tan x, minus g prime. The derivative of tan is secant squared. So minus secant squared times the top, 1 minus secant x. Over g squared, simply put tan squared x. So we have f prime g minus g prime f over g squared. We are going to distribute. When we multiply these two, we get minus secant x tan squared of x. When we distribute this one, we get minus secant squared x. And then with the last one, we get plus secant cubed. We notice every term in the numerator has secant x. So we are going to factor out the secant x from the numerator, secant x. When we do that, the first one becomes minus tan squared. This one becomes minus secant x. And this one becomes plus secant squared. So again, the first one, minus tan squared. The second one, minus secant x. And the last one is secant squared x. We remember one of the Pythagorean identities in trigonometry is that 1 plus tan squared is secant squared x. And we see something happening here. So if we move the tan squared to the right, secant squared x minus tan squared x is equal to 1. And that's exactly what we have here, secant squared x minus tan squared x. In other words, we have this one and this one, and the 2 will give us simply 1. So inside the brackets, we get 1 minus secant x. So the final answer, y prime, is secant x times the brackets 1 minus secant x over tan squared x. And that is the final answer and the simplified version.